Hello everyone. In this project, I worked on a customer churn prediction problem using the telco customer churn dataset. Customer churn is a critical challenge in industries like telecommunications because retaining existing customer is significantly more cost effective than acquiring new ones. The main goal of this project was not just to build a prediction model, but to compare multiple machine learning models using a structured and reproducible workflow and then select the best performing model based on the objective evaluation metrics. I started the project by importing all the required Python libraries such as Pandas, NumPy for data handling, Matplotlib and Seaborn for visualization, and scikit-learn for preprocessing, model training, and evaluation. I also fixed a random state throughout the project to ensure that the results are reproducible, which is an important best practice in the machine learning. Next, I have loaded the telco customer churn dataset and performed an initial inspection to understand the structure of the data. This included checking the column names, data types, overall shape of the data. At this stage, I have verified that the dataset contains a mix of numerical and the categorical data along with the churn which target variable churn which indicates whether a customer has left the service. After the data, I have moved on to the next step, which is one of the very crucial steps, that is data cleaning. One important issue I have addressed was the total charges column, which was stored as a string instead of numerical values. So I have converted this column into a numerical format and removed the rows with invalid values. I also encoded the target variable churn into a binary form where 1 represents churn and 0 represents non-churn. These steps ensured that the dataset was clean and suitable for machine learning models. Once the data was cleaned, I performed exploratory data analysis to better understanding the customer behavior and churn patterns. I visualized the churn distribution to see how balanced the target variable was. I also plotted the distribution of monthly charges to understand the billing pattern and creating a correlation heat map using a numerical features to identify the relationships between the variables. This analysis helped me gain intuitions about which features might influence the customer churn. Following the EDA, I have implemented the feature engineering. To enhance the dataset, I have created a new feature called tenure bucket, which groups the customers into short, medium, and long. So this helps capture customer loyalty pattern. I have also created another feature called charges per tenure, which normalizes the monthly charges by customer tenure. These engineered features allows the models to capture customer behavior more efficiently. So these two columns can you can notice that these two columns have been present in the dataset by adding them. After feature engineering, I have separated the dataset into input features and the target variables. So the input features can be represented as here as X and the target variables as Y. So I have also explicitly identified the numerical and the categorical columns. This separation was necessary to apply different pre-processing techniques to different feature types in a clean and an organized manner. To ensure consistent and leakage-free pre-processing, I have built a pre-processing pipeline and column transformer. Numerical features were standardized using the standard scalar, while the categorical were encoded using one-hot encoding. This pipeline ensures that the same transformations are applied consistently during training, validation, cross-validation, and then the testing. So the main step would be the data splitting. So the data set was then split into a training, a validation, and the testing in the ratio of 60 to 20 to 20. I used stratified splitting to maintain the same churn distribution across all the splits. This approach ensures fair model evaluation, prevents bias caused by class imbalance. So here in the code you can see that the data has been split into three different categories, and the values of the X train, X validation, and text X test shape have been printed here for the better understanding. And the main step, the model selection. For model training, I experimented with three different classification algorithms like logistic regression, random forest, and support vector machine. Instead of training them separately, I used a structured comparison approach that allows all the models to be trained and evaluated using the same pre-processing pipeline and data splits. This makes the comparison fair and reliable. I evaluated all the models using the multiple metrics, including accuracy, precision, recall, F1 score, and ROC-AUC. Among these, ROC-AUC was the primary metric because it provides a balanced measure of performance, especially in the classification problems like churn prediction. These results show that the logistic regression have achieved the highest ROC-AUC score of approximately 0.85, followed closely by random forest and then the support vector machine. I have created a comparison table on the validation set to clearly see how each model performs. I have also plotted ROC curves for all three models on the same graph, which helps visually compare their ability to distinguish churn and non-churn customers. For model interpretability, I analyzed the feature importance from the random forest model. This helped understand which features contributed most to predicting churn, such as tenure charges per month, and the contract type. Based on the validation results, logistic regression received the highest ROC AEC score of around 0.85. Random forest and SVM also performed well but slightly lower. I suggested random forest as a final model because it offered the best overall ROC AUC uh, score. It has given a consistent performance, simpler interpretation, better computational efficiency. When evaluated on the held out test set, the model achieved an ROC-AUC score above 0.80, meeting the project requirement. So, to conclude, this project demonstrates a complete machine learning pipeline from data exploration to data comparison and final selection. By using proper pre-processing, cross-validation, and multiple evaluation metrics, the project highlights the importance of evidence-based model selection rather than relying on a single algorithm. Thank you so much.